I would welcome you all to this introductory session to AWS Cloud Platform. Myself, 𝐒𝐭𝐚𝐲. I'm a software developer at Expedia Group, primarily working into the cloud engineering space. And I've been working with Expedia since last 6.5 years. And most of my time was devoted into the cloud engineering and development around it. Just moving through and just assuming that most of you do have a basic understanding of what cloud computing is nowadays and why we are picking on AWS itself, why not other cloud vendors like Google Cloud or Azure. Or, there are some in-house tools as well, so and so forth. So the agenda for today's meet would be basically around all these 5 pointers. Firstly, we'll go and talk something about cloud computing, creating a fundamentals of what we are going to discuss in the further slides. It will give us a good fundamental knowledge and a base of what is getting discussed and where we can take this knowledge forward to. Then we'll talk about the Amazon Web Services platform. We'll also talk about the global infrastructure which AWS provides. And then we'll talk briefly about there are so many services from AWS. What are they? In what category they lie and what we can use them for. Then lastly, we'll talk about the access, how we can access the AWS services and how I'll give you a live walkthrough demo to the AWS console. So without further ado, I'll start with cloud computing. So cloud computing is what it's more like you're doing a remote compute jobs. Cloud computing means you're just connected to the compute resources over the internet, and then you are utilizing those resources. They are lying it somewhere on the uh, on the geography, like anywhere, but it is just that they are all accessible to you via the network, and they are interconnected within themselves using that network. So gives you less of the connectivity latency and all. We'll talk about that further if time is there. So cloud computing is an on-demand delivery of compute power, database storage, applications, and other IT resources through which we can use to develop our applications and all. And the best thing is that we do not have to pay for everything. We just have to pay for whatever we are using. For example, if I am using if you have a data center and if you're having a CPU over there, so you'll have to pay for that CPU for like forever, because you own it, right? The cost of ownership comes in there. But if you have a instance, the similar configuration that your CPU has in the data center, now you don't have to pay forever. You just have to pay for how many hours you're using it. It's it can be related to while you start the ignition of your bike, you're consuming the fuel, but while it is off, you're not using it, right? So the cloud is comprised of different services. It can be compute service, it can be networking service, it can be database service, and whatnot. These days, everything is on cloud, like all the DevOps tools, every toolkit that you use. For example, Chef, you have CI/CD pipelines, you have your deployments. Everything is there on cloud. Everything is available there. Just that you have to think around what the what the problem that you're trying to solve and what the solution AWS is providing in this case of the meetup. And then we can correlate like how much of my problem can be solved with this service of AWS. And cloud computing enables us to stop thinking of the infrastructure and hardware, meaning that less cost of ownership and more productivity in terms of what we need it for. We'll talk about that parameter in the coming slides again. So there are three different models of cloud computing you might have heard of, and there are more which are evolving these days. Primarily, we started the journey of cloud computing from infrastructure as a service, meaning that whatever I'm using out of any cloud vendor, I'm just using the infrastructure resources, because over there I just have like, for example, from AWS, I am using like one service XYZ. And what the service is giving me is, it is giving me the number of CPUs, the RAM. Is my screen not visible, Rishabh? Cool. So moving ahead, I was just talking about the models of cloud computing, meaning that how what category of service we are using out of that cloud computing thing. So first and foremost, the thing is infrastructure as a service, which is, as I was giving you an example. So AWS is now giving me XYZ service, which I can give a customization saying that I need 5 cores of CPU, vCPUs, and I'll be needing 2 gigs of RAM. And I'll also talk about the storage and all. So this is something that I am giving as a requirement to them. But then on top of that, I'll have to utilize those hardware resources by installing the operating system, by creating a platform, and then deploying my service on it, and then make it live. Like the application will go and run in the expected way after that. Similar to what you have when you bring in a new system to yourself. For example, a new laptop, you install an operating system, you install the Java runtime, for example, and then you run your Java applications on top of it. So that's the case for infrastructure as a service. Now, again, the second thing comes in as platform as a service, wherein I do not have to manage the underlying hardware. I do not have to even manage the underlying operating system. In this case, what I'm expecting out of platform as a service is, it is giving me a platform where I can just go and run my applications on. For example, I can ask for a mobile application platform, which is Elastic Beanstalk, wherein you are just getting the platform. You can directly deploy your application on it. You don't have to even install any binaries or so to support the running of your application. Then comes the most like the most evolutionary service, which is software as a service, wherein what you have to do is, you have to just use the services. You do not have to take care of the hardware. You do not have to take care of the operating system. You don't have to take care of the platform, and you do not even have to take care of the application itself. Everything is being managed uh, by the cloud provider, in this case AWS. So software as a service can be something like, you can think of that as Lambda. So you're just providing your code there. It is executing it and returning back the expected output to you. So these are the three basic models of cloud computing. And any questions till now? Cool. So moving ahead, let's talk about the deployment models. Now that let's suppose I have now decided. So just think of this whole presentation as a story. We are taking one step at a time, and we are moving ahead, and we are thinking of, okay, what all we have. Firstly, just giving you a brief summary right till now. We understood what cloud computing is. We then understood the models of cloud computing as an infrastructure as a service, platform as a service, and software as a service. What service we want to use in what way, how much flexibility I want in terms of managing that particular infra platform or application, and how much freedom I want to give to my development community, to my developers, and how much flexibility I want, how much productive I can convert while I shift the things to cloud. Now let's talk about the cloud deployment models in this way. So while let's suppose I have a company, XYZ, and now XYZ is thinking to move its infrastructure from something to cloud. So that something can be my own data center. So what I can do, it's either I can go and deploy everything on cloud, move everything to cloud. So basically, what happens whenever you talk to any person or any organization which is running their business in the data center environment on their own on their premises, like they do have their own infra and everything. They're managing all of it. So when you talk to them, most generally, like mostly what they come up with is like, okay, we have to, we only know like two things. One is like we are on-prem, or otherwise we are just moving to cloud. There is nothing in between. It's just 0 and 1. But it is not the case. There are so many companies which are running their business in a hybrid model. So starting from all in cloud is that you have all your infrastructure moved in cloud. So how this story starts, let's start from bottom. We can you can think of it as like evolutionized in this way, like, or you do a migration journey in this way from bottom to top in this slide. So private cloud on premises, which is that um, you are either using any virtualization within your on-premise infrastructure, and you are using some private clouds in there. For example, one of that is um, the one coming from Red Hat, and that is private. So that is deployed into your infrastructure, and it has nothing to do with the public cloud. So there are two different models, like public cloud or a private cloud. So that's a private cloud that you deploy on premises and utilize your infrastructure from the data center. Then now you think of moving things to cloud. For example, the same story, you are using some Red Hat um, a private cloud in your data center, and you now wants to move some applications to AWS. So how you can do that, how you can achieve that? Cloud terminologies remain like terminologies may differ, but their actual functionality remains the same. So IaaS will always be IaaS. IaaS will never convert into PaaS, right? So what will happen, you'll have to understand what applications in your private cloud are there in which category of business. Like, is it a application which requires me to test the IaaS functionality or PaaS functionality, or in case if SaaS is available in AWS, then okay, let's move that way. So first step is the hybrid deployment model, wherein half of your or some part of your applications are running on premise and some part of your applications are running on cloud, in this case AWS. And then slowly and steadily, when you see expected behavior, sorry, private cloud stand in which cloud models? Cloud models as in you're talking about the IaaS PaaS? Okay, yeah, got it. So those are not cloud models. They are likely, just let me take you back to that. So these are the models of cloud computing, and all of these three functionalities will remain same in any of the cloud model, like the deployment model. So private cloud will also have IaaS, PaaS, and SaaS. Then your public cloud will also have IaaS, PaaS, and SaaS. Those are like cloud computing models, and this is the cloud deployment model. So this particular slide comes in to action when you decide on what platform you want to move. Does that answer your question, Rishabh? Thank you. So yeah, next thing is like once everything is settled, once I have tested all of my applications in beta phases and everything, alpha, beta, and all, I now move all of the things in cloud. So any company can think of this way. They can either move everything to cloud directly, or they can have some part in their on-prem if they have, and some part in cloud. Or in case they are not willing to move to public cloud, they have some restrictions in terms of like the business cases and all. It all depends case to case. So they can opt for a private cloud option. There are so many options which are available in market, which are there for private cloud. So I think IBM provides one, and then Red Hat is also one which provides that functionality to you as a user. Now, if I talk about and compare the all cloud versus on-prem, okay, so just think in this way. As I said, if I give you an example, I do not have a whiteboard right away, but Just try to visualize it with me. What I'm saying, in a data center, and on-premise means my own data center. So as a company, if I hold a data center and I am having 10 servers over there, every server is having 50 CPUs and let's suppose 32 gigs of memory. Okay, so and this is multiplied by 10. So 50 into 10, that's 500, and then 32 into 10, that is 320 gigs of memory and 500 CPUs. So all of these CPUs run like 24/7, right? We are not shutting off the data center, even if it is like the request which is coming to the data center is low or high or what. So this is the case wherein like you can see this over provision or the waste, because the blue line, you see, can you see where I'm highlighting on the screen? Yeah. Okay. So you see this blue line running over, right? This is a traditional graph of how my requests are coming into the data center and what I am doing with it. This is the forecast demand. So it says like, okay, demand will increase this way. Maybe this is the 0th hour of the day, and then within like as the time as the time goes on, so the traffic shift will remain constant. But what happens in the real world scenario is like there are times in a day. For example, Expedia is a travel company, right? Nobody books a travel, most probably nobody books a travel in the night around like 12 to 4 a.m., right? So just imagine this particular graph is 12 to 4 a.m. And then after 4 a.m., there is a huge spike in traffic, in number of requests which is coming till let's suppose 5 p.m. in the evening. And after that, it goes the same, like under. But your resources are running every time, right? So what you are doing in this case, you see this point, this green area, this is the overutilization. So this is a resource that you're wasting. You're running 10 servers, but out of those, only 2 are getting used. 8 servers are there. They're still running, but they're not, giving you a return of like in terms of they're not taking any traffic at the moment. They're just running. So you can think in this way: you have 10 cars and only 2 of them are like 10 of them are on, the ignition is on, but only 2 of them are running. So 8 of them are standing and they are utilizing the fuel. Okay. And what happens in the other case wherein so you already forecasted that there can be because you have provisioned 10 servers in your data center. So you can think of only situations wherein only 10 servers can handle the request. So let's suppose each server can handle 5 requests. Okay, so 10 servers can serve 50 requests in a second. Okay, how about if you get 60 requests in a second? In the data center environment, you will fail to serve those extra 10 additional customers. Plus, there will also be an impact to the existing 50 customers in terms of they'll be facing latency and whatnot. So if I think of the same situation in cloud computing gives me that flexibility, right? What happens in there? I do not own any server over there. I'm just paying for whatever I'm using, right? If if I require just 2 cars, they'll just give me 2 cars with ignition on and they are in the running state. When I'll be needing more cars, it will be giving me more cars and they'll be in the running state. But once I'm done with the usage, I'll just be back with like 2 cars again. Okay. So you see there is a optimization in terms of the usage and in terms of the total cost that you pay in data center while on and where like comparing that to all in cloud. Also, the other scenario that I was talking about is 50 to 60 um, ramp up, meaning that you had your infra ready for 50 customers. If you now have 60 customers, so accordingly, there will be a scale up in the services and there will be a relative scale down in the services. So your instances will spin up accordingly. You'll have more instances, you'll have more peer instances. So with 2, now you'll have 3, and 3 will be running and taking the traffic. So there will be no impact in terms of how much traffic, how much the number of requests that you're getting at that moment, and there will be no impact in terms of the end user experience. This is where the cloud computing holds, you know, uh, uh, improvement in, as compared to the on-premise. Now, let's get in this specific detail for AWS, Amazon Web Services. So, this is how Amazon Web Services, in terms of their global infrastructure, looks right now. So you have these blue dots, which are the available regions right away, right now. Like right now, they are in the running state. In India, they have one, and they are now planning for one more. So the red ones that you see here, they are the second. They are the like upcoming data center, upcoming regions. As in terms of when you go to the console and you check, I'll give you a walkthrough to that, how you see and map these regions to the console. So right now, AWS is spanned across 84 availability zones and 26 geographic regions. So over here, you see these blue dots. These are 26 in numbers. And then within those regions, you have availability zones. We'll talk about that funnel as well. And then AWS is also planning for 24 more availability zones within those like new 8 AWS regions in countries like Australia, Canada, India, Israel, New Zealand, Spain, Switzerland, and UAE. Okay, any questions till now? Cool. So yeah, look, let's move forward and let's talk about, we have talked about these regions and availability zones. What are these in actual scenario? So regions actually map to actual geographical location. So over here, if I tell you, so these blue dots are the regions. Okay, so this blue dot in India is one, and then in US you have one, and so on. So these are the actual geographical locations wherein you have the AWS services available. Now, what's coming inside that region is the availability zone. Why do we need availability zone? Any idea? Any guesses? Or in like why there is a need of the availability zone? Cool, no problem. So basically what happens, you have heard of, sure. Okay, so I was just asking that what you have the geographical region, and then that geographical region is called AWS region, that area. And then within that region, you have multiple availability zones. Do you think, what do you think is the need for availability zone? Uh, the thing is, when we are even using the data center environment, you might have heard of the terms like DR, active, passive, and things like that, right? Just to make sure, what's the purpose of a company who is investing in data center or in any of the compute resource? If they are, for example, a company like Expedia, not exactly, Rajendran. I'll get to that point. Maybe post that I'll ask you if things are clear. So yeah, uh, for a company like Expedia, what happens if I am serving um, a customer? Let's suppose you are going to Expedia.com, and it's not landing page. It's not landing the page it is giving you 404 or things like that. You'll be looking for some other company or some other similar business, right? And then you'll be going ahead. So what is the motto of a person or an engineer who is working in that domain is to make sure that everything is up and running all times. So at any point in time, my services should be available. For me, the responsibility is that Expedia.com should be up and available all the times, whenever a user is trying to get in there and try to access that URL. So how do I make sure that that is actually happening? So if I have my data center, I have one server wherein this particular web service is running. Okay, you are going to www.xyz.com, you're landing onto it, and it is working. Now that is running on one server, server A, and now what happens? Somehow there is a power outage, and this server A goes down. What happens? There are two things that can happen in this way, in this case, and I'll tell you the reason behind both of these. So first reason can be a power outage happens, and what can happen is like the user will get a 503 or 404. It's not available. Most probably a 404, not 503. 404 will be there, and you'll be like it will be a bad customer impact, bad user experience, right? The other thing that can happen is even if server A goes down, my services are still getting exposed. My services are still available. How? Because I have deployed the same replica of that application of that web application onto a different web server, which is server B. Okay, so that is called the disaster recovery strategy, or the recovery strategy, or active passive work, wherein server A in this case was the active case and server B was a passive one. So whenever there is anything goes wrong with the active server, what happens? That primary becomes active and the active becomes primary, because we have to take down the server which is not working fine. We have to fix it and we have to put it back in rotation. So this is the role of availability zone. So availability zones, these are isolated areas. They are separate in terms of power, in terms of network connectivity, and also they are also designed in such a way that they are put in a different seismic zone. So let's suppose my services are running in two AZs. If I have a highly available service, what I can do is I can actually make that service deployed into multiple availability zones. So all the regions in AWS will have at least two availability zones with them. Okay. So A and B, likewise, 1, 2, A, B, whatever you can imagine right now. I'll just show you that on the console also. So there will be two terms which will be coming in terms of your deployment of your application. So let's suppose you have a web application and you want to make it highly available. How will you make sure your application is highly available? You'll be deploying your application into two different or more than one availability zone, so that whenever, if there is anything that happens, a natural disaster happens or anything that happens, one of the availability zone goes down, other one will take the traffic. So Rishabh says, operate applications and databases that automatically transition between zones without interruptions. Okay, so you are saying availability zone is something that operate applications and databases that automatically transitions between zones without interruption. Somewhere right, but it does not operate anything. It is just that you are deploying you are deploying or installing your services in two different places in the same region. So if you're let's suppose in the previous slide when I showed you this one, India is having one region. Okay, so within that region itself, if I have deployed my service and I want that to be highly available, I'll make sure that my service is available, is deployed into two availability zones, A and B. Yeah, replica set. That's fine. That's correct. And then whenever there is anything that happens within one of those AZs, the other one will take care of it. The other term that I was talking about is your application globally available or not. So if you want your application to be globally available, you have to make sure that your application is deployed across different regions in AWS. How? Let's suppose my user is sitting here, okay, and my services are also deployed in here. But what if my service which is deployed in here is also getting requests from here and from here and from any remote place in the world? they'll face a network latency because the path from this to this and path from within it is related. There is a difference between that, right? So that path you can directly proportionalize to the latency in terms of when you try to reach out to that service. So you might have encountered at times when you try to load a page, it takes time for you to, for your browser to load that page, just because that service is not closely kind of deployed with, like closely deployed with within your geographical range. So there are things like edge computing and all, which provides the cached systems and all. They are like somewhat advanced topics which I'll not be covering in this case, but just throwing out so that in case you are interested, you can actually have a look at that in Google and search out for what edge computing is. Okay, so availability zones in a region are connected through low latency links. So uh, it is as simple as that. You zoom into this particular region, this blue dot that I'm highlighting. You zoom into this, and you see three different availability zones coming in. You see three different new dots coming in. They represent three availability zones within that region, and they are connected through low latency links, because for anyone outside that region, they are one single entity. That's the region. And we choose any region to optimize latency, minimize costs, and regulatory requirements. So regulatory requirements is like a separate thing, but just to give you a glimpse of the first two is optimize latency. I have already told you about that. If you have customers coming in from global market and want to access your web page or your services, then you'll have to make sure that you are at least making the services available in the places where or closer to the places where you are getting the requests from. Now, it is not necessary that if my service is global, I'll have to make sure that I have to deploy it in all of those regions. So I'll have to make sure, just to make sure that I am investing minimized costs across those. Is that so? Okay, I have one application deployed in this region, so this makes sure that all of these regions can suffer. This much of latency can suffer. This much of latency can suffer, right? But if I have second replica or second region of deployment is this, and third region of deployment is this. Okay, so this is like equally distributed, and it can be more. Depends on from where in the globe you're getting more requests from. So this is about AWS regions and availability zones. Just give me a heads up if you are clear with these terms, and we can move forward, or if you want anything in specific, do let me know. Cool. So moving ahead, let's talk about the Amazon Web Services now. Getting into the gist of it. What Amazon Web Services is, it is actually a suite of all different sorts of applications. You can think of it, can be a compute application or a compute service. It can be analytics service. As I said, like initially when I map it to IaaS, PaaS, and SaaS, so there are application services. Okay, these are like software as a service. Then you have compute services. Okay, so these compute services are directly like your IaaS, because you are actually asking for this much of CPU, this much of RAM, this much of storage, and all. And when you talk of the platform as a service, then you are looking for a already built platform wherein you just want to go and deploy your services to. So things like mobile services, things like something like Elastic Beanstalk. You can actually read about that. That provides you a platform already developed, and then going through this list, then you have there are compute services, there are analytics services. So you are running your data on compute, you're running your databases, you're running your mobile services, you're also having some network created. Then you want to run some analytics on that. How much of my compute is like how my compute platform is kind of performing, how my databases are performing, is there anything which is going out. So based on the diagrams that you remember, like I showed you like earlier in this session, comparing the on-prem and the all cloud infra, you can similarly think of any application which is running on compute platform, and then you want to know how much in terms of the network in, network out, how it is performing, where I can do better. Because after looking at those graphs, after looking at those metrics, you'll get to know where you have to perform better, where you have to scale in more, and where you'll have to scale out. So you can actually compare it with this factor, minimize the cost and optimize the latency. Okay. So because on compute specifically, you'll see the network in out. If the network in is X and network out is Y, you'll have to make sure like the difference between X and Y is something which you are expecting. It should not be a good like big band. Otherwise, it is a latency problem in your infra. Then you have some developer tools. Then you have enterprise applications. You have security and identity, which is IAM. And then you have some management tools, Internet things, application services, networking. Within networking, you have like VPCs. You might have heard of it by now. VPCs, then subnets, security groups, and whatnot, Internet gateway. There are so many things. If you want to immerse down to AWS, there are so many things into it. Okay, so let's talk about few of the services. I'm just taking you through a very brief of it, and we'll be categorizing them into different categories. For example, these are very core services. Like if you are very new to AWS, your organization is very new to AWS, and you want to use AWS, you want to try it out, you want to look at how things are performing in this domain. How do I have to make a shift to cloud, specifically to AWS? Where do I land? You can land in here, and you can have a knowledge in here. So there are categories like compute services, then you have networking services, you have storage and database. I think these are the four basic things that you need when you know create or deploy an application from scratch. If you want to create something in terms of a data center, you'll think of it right in this way. You'll have to create a network first, then you'll have to have some compute resources on that. You'll have to think on those compute resources. There will be some storage needed. So you map it to the storage. And maybe there are some applications which are writing data to the database. And you have multiple, options of database. For example, it is like the relational database. Then you have DynamoDB, which is NoSQL database, and then things like that, right? So this is a very core area, or like the core slide wherein you can think of these are the core services coming from AWS as a category. So AWS Amazon EC2, which is Elastic Compute Cloud, cloud compute machines. These are the virtual machines. Then you have AWS Lambda. You have Elastic Beanstalk, which is platform as a service. You have auto scaling services, which I have already told you. Like if your traffic shifts from 50 to 60 requests per second, then how you will handle it. So you'll be handling it with auto scaling in place. Then you have ECRs, the Elastic Container Registry. So you might have heard about something like the Docker registry, wherein if you create Docker images and all, you can push those images to the registry. You can have them there, and whenever you need it or anyone else is needing that, so they can pull it from there. Okay. And then you have Elastic Container Services, the ECS service, which is also the container service is mostly run around. There are two different types. One is like instance based, and the other one is there is one more. I'm just forgetting that name. Fargate. Fargate is another mode wherein you don't even have to manage think about the underlying infra in terms of the instances that you're running. Then you have Lightsail and AWS Batch, and you can read about them in detail. I'm not going in detail for any of these. Is ECR uses servers? So it is basically a registry actually. If you are creating, and can you be more elaborative in terms of what your question is in specific, so that I can actually try to answer it? Okay, EC2 uses server. Yeah, EC2 is instance. Exactly. EC2 is instance. So let's suppose you are using some Docker image and you want to put that Docker image locally on AWS. See, there there is a difference between your EC2 making a call to the Docker registry, which is available on the internet, and the other path is the image which is available in Elastic Container Registry. So which one will be pulled faster? Your ECR will be pulled faster. The image which is put on ECR will be pulled faster because it is internal. So something, for example, your laptop, the internal hard drive is it is accessible like faster as compared to an external hard drive which you have attached, or a network drive. Now, networking, you have VPCs. VPCs directly map to your AWS regions. So every region and VPC will have one-to-one connection. And then you have Route 53, which is a DNS service. It resolves the requests, which so you can look at an example of Expedia.com. So I am masking Expedia.com, and there are some servers running. So EC2 is running, and there is a elastic load balancer on top of it, and this is having some non-human readable DNS name. So I'm putting that in Route 53 and publishing that as www.expedia.com. So that is published outside, and people can actually land into this EC2, the services which are running on EC2 or underlying infra, after going on to that URL. And there are things like AWS Direct Connect, which the intention of which was to connect and work mostly in that hybrid deployment model, wherein you have some pieces of your work or applications lying in the data center and some of them lying in AWS cloud. And then you have storage services, and then there are some database services. Let's move to next group of services, which is the foundational services. Then you in this category, you'll have some analytics. Now that you have the core services in place, you actually want to know the insights of it. So you use something like EMR to process your data. You have data pipelines to make sure everything is going in an automated way. You define a data pipeline and it goes. So you define a data pipeline, meaning that Excel sheet which is uploaded on the S3 bucket, and you want that to be populated into the database. You use the AWS data pipeline. Just as an example, there are so many other features it has, but I am just telling you one of those. And then you have Elasticsearch, Kinesis, and Athena and Redshift, and so many other services like that. Then you have enterprise apps like Workmail, Workdocs, Workspaces. It is another suite of applications. Then you have mobile services like SNS, and then you have SDKs, and there are so many services which are also like new, might not be available in this slide deck, but you can actually explore that. I'll give you a glimpse of the while I'll give you the glimpse of the AWS console. You'll get to see how this category is visible over there, how you can map it there. Then you have Internet of Things, like AWS IoT is one of the service. Then you have some developer and operational services, which includes code commit, code deploy, code pipeline, code build. Now, if you are a DevOps guy, you actually can correlate them with AWS code commit as GitHub, code deploy as Jenkins, code pipeline as any pipeline tool that you're using, code build again as Jenkins and X-Ray and whatnot. So management tools, you have CloudWatch alarms, you have CloudFormation, AWS config, and services like that. For security and identity, you have IAM roles, you have the directory services, you have Shield services, certificate managers. KMS is also one of the service. And then you have some app services. So SES, SQS, SNS, SWF, like it is a workflow. So this is the category for developer and operation services. Now, the big question, now that I know all of these things, how can I go and access these AWS services? So there are three options to it. If you are if you are very new, you can actually go and check for directly to the AWS management console. It's a web-based console. It is available on the web browser. Plus, there is also an app which you can use for AWS. Then, if you are someone who likes things to move fast and are more likely into the space wherein commands are you're closer to the command line, so you can use the AWS CLI to go and interact with the AWS services that you're using for the account. And then you have some software development kits, the SDKs. So for that, it is that you want to use those AWS services via some code. So just to give you an example, you can, if you are a Python programmer and if you want to use any of these services, you want to deploy your code, you want to provision these services, you can actually do that using Python. There is a library called Boto3, which you can use, and you'll be able to interact with the services, with the AWS services from Python. And similarly, there is a library for Java and other applications. Any questions till now, or are we good? No, in terms of you're not clear, or no, in terms of you do not have any questions? Okay, cool. Awesome. So let me stop sharing my screen and I'll share the screen back with the AWS console. Just give me 1 second. Okay, sharing my screen again. Just do let me know if you're able to see it. Cool. So you can actually go and have a free, there's a free tier of AWS account. So they give at least the core services, a part of it, for you to try them out for free. And like for a limited usage, but I think it'll be a good one for you to get a good grasp of what that actually does. So this is how the account, the AWS console looks like. You have different services all mentioned here, and look at all services. There is also a category of service. So this is how I was. Are you guys able to see my screen first? I'm so sorry, I forgot asking that. Okay, cool. So you remember on the slides, I was showing you the fundamental services and whatnot. So this is how you categorize it all in terms of like the compute services. You have container services, like separately you have storage service, database, media service, and like there are so many headers to it. Like you can actually go through it. And then the AWS regions. So these are the AWS regions. This is like US West 2, and you can see there is one for Mumbai, AP South 1. And okay, so this is the region, okay? And if you want to actually check for what all availability zones falls inside it, let's have a look. So let's see. So if US West 2 is my region, then US West 2A, 2B, and 2C, you see these. So you see these availability zones, US West 2A, 2B, and 2C. So these are the availability zones. And within those, within these availability zones, you have the things called data centers. So the granularity is something like, I go back in here. If you actually zoom into this picture, These are the regions. Within that region, if you zoom that in, you'll get the availability zone. And within a availability zone, if you zoom in more, you'll get to know the data centers. And there is a security policy which says AWS, like if there are two data centers which are like closely present in terms of like the geographical location, they'll not even know uh, if they are like working with AWS. So they cannot talk to each other in terms of like, okay, I'm also working with AWS, and the other one can say like, I'm also working with the AWS. So this is like a security compliance they sign up. Yeah. So that this is pretty much it I can share in for today. Any questions I can take now? No questions from Rishabh. Anyone else? Cool. If there is none, we can call it off. And thanks a lot, all of you, to be here on this session. And you can reach out to me or the group or the team in case you need anything. Thanks again. Have a good day. Bye bye.